Welcome back, Exceptional Ones. It's Prof G, and in this lesson we'll go over a solution to the volume-controlled audio play challenge that was presented at the end of our lesson on limiting audio pops and clicks and controlling volume levels. Let's compare answers. Now, this solution combines two prior lessons. One was the solution at the end of the lesson on spin neopixels, volume gauge, and list comprehension. The other was what we learned in our last lesson on stopping pops and setting volume levels. If you're new to the channel, feel free to dive into the sequential playlist to examine awesomeness that came before. And for everyone else that's ready for the solution, let's crank up the big learning. As a reminder, a working solution should look like this. It starts off with all lights off and the volume turned off. Now pressing button A will turn on a red light one at a time, and this also brings the volume up one level. After 10 presses, we're at full volume, all the lights are on, tap a touchpad, and the sound of your choice will play. Then button B will turn down the volume one tap at a time. Here it is at volume halfway. So the volume is at half as well. Let's go down to 1. And at 0, when you tap a touchpad, no sound should come out the speaker. So make sure your Circuit Playground is plugged in. Let's get into PyCharm, and I'm going to start by pulling up some earlier code that we wrote to handle the button presses and lights. We save this to our CircuitPython school folder as volume button display list comprehension. If you want a refresher on how this code works, or you're new and you need to code this up, you can see this earlier lesson. I'm going to highlight all of this code and copy it, then close this outermost tab, and with code.py open, I'm going to paste over the code that's in there with my volume button display list comprehension code. And why don't we open the terminal and get into TO really quickly and run this code just to make sure everything's working okay. And pressing A turns on the red lights, holding it down will turn on repeated lights, and B will turn off lights. You get repeated lights here, and if you go all the way to the end, all the lights are off. Cool. So I'm going to change the comment up top to read volume-control. That's what the challenge asked us to save this under. And normally I advise students to write code from scratch when they're learning, but writing code as a maker is a little bit different from writing code as a software engineer. That's the sort of class that I teach when I teach my apps class. And more often than not, with smaller maker projects, you can raid old code and treat the code that you've previously written as sort of software Legos that you can snap into place to get the functionality that you need. So since there's a lot of code that we need and we've already written it and we've explained it in prior lessons, I'm just going to raid our old code. So to get the touchpad code, I'm going to raid the drum machine Py code that we wrote from an earlier challenge. This was the one where I also demonstrated the fruit drum machine. So I'm going to go to File, Open, and pull this up in a separate PyCharm tab. And always make sure you're paying attention to which tab is active so that you're coding in the correct tab. PyCharm puts a little thicker line underneath whichever tab is open. So to work with touchpads, I remember I've got to import touch.io. So I'm going to make sure that I import touch.io over in code.py, then head back to drum machine. And I'm going to get this setup code that I've highlighted here. So from setup touchpads through this for loop for pad in pads. And just as a reminder, I set up a list containing all 7 locations of the touchpads in my Circuit Playground board. That's called pads. And I also create an empty list called touchpads. Then I iterate through all of the pad locations with 4 pad in pads. I create a touchpad using touchio.touchIn, passing in a pad location. That's what the pad variable is. It's one of these guys. So this is sort of the touchpad equivalent of creating the digital I/O object and setting it as input when we create a button. And so this code creates a touchpad that's a touch-in object, and then this append statement here adds that touchpad object to our touchpads list. That list started out empty, but by the end it's going to be filled with 7 touch-in objects. And at this point we've got a list named touchpads. It contains 7 elements where each element is a separate touchpad, and each of those separate touchpads acts sort of like a button. So again, make sure you've highlighted all this code and copy it, and then let's head back over to code.py. And in code.py I'm going to paste this in just after we set up our buttons and before we set the volume equal to 0. Then let's head back to the drum machine tab, and the one more thing we want is to be able to detect when these touchpads are touched. So that's this code here in the while true loop. I'm going to highlight it, copy it, then return to code.py. And in the while true loop here, after I've handled the if button A value, if button B value, I'm going to outdent even to both of those if statements, and I'm going to paste in the code that I just copied. And if touchpad I is pressed, I'm not going to use these 3 lines here. I'm going to delete them. For now, why don't we just print out that a particular touchpad was touched? So we'll just test out the touchpad code at this point by saying print in parentheses, and this will be an F string with double quotes, pad, curly braces, I, touched exclamation point. Then we can click to get rid of the drum machines tab. We don't need that code anymore. And now let's open the terminal, make sure that you're in TO, and let's save the work and try this out. So my buttons still work, and let's touch pads. And we can see the buttons aren't to bounce, but it's definitely detecting the different pad touches. I can see what's printed out in the console. Cool. So I'm going to close the terminal and scroll up top. And now let's open up some code that worked with audiomixer. So since I have a Circuit Playground Bluefruit, I'm going to choose audiomixer MP3 play Circuit Playground. If you have a Circuit Playground Express, you should probably get the WAV code instead of the MP3 code because you can't play MP3s on a Circuit Playground Express. And the first thing I'm going to do is grab these imports. So I need to import from audiomixer through my double try statement, copy all these statements, and let's head over to code.py. And I'll paste this right after touch.io, and I should have put a comma after touch.io first. Always look around to see if you have any red squigglies of anger in your code. Add my comma, and the red squigglies of anger go away. And I'll add a space just above the from Adafruit LED animations, just to make it easier to see separate statements in my code. Now back in my audiomixer code, I want to copy all this code starting from where I import the 3 lines to set up the speaker for the CPX and CPB, all the way through to where I create the MP3 decoder, so make sure you've highlighted all of that code, copy it. We'll return to code.py, and why don't we paste it in just after we have this for loop where we loop through all of the pads and just before we set our volume equal to 0. So this looks good. It sets up our speaker, our audio out, our audio mixer, and our MP3 decoder. We describe all this code in our previous lesson, so we won't do that again now, but let's head back to our audio mixer code, and we absolutely need the function that's going to play our music file. Since it's the MP3 example we're using here, I'm going to copy this function definition, play MP3 voice, head back over to code.py, and why don't I paste that just after the volume equals 1, but above our while true. And finally, we want some code that's going to set the volume level, that's this mixer voice 0.level. And why don't I go ahead and call play MP3 voice passing in encouragement 2. So I'll copy these 2 lines, head back to code.py, and when I loop through all of my touchpads, if a touchpad is touched, I'm going to go ahead and paste this in right underneath where my print statement is. Remove the comment where I set my mixer voice level, that's the volume. No, I don't want to set this to 0.25. I want to set this to a variant of the volume that I changed above. So we're using this variable volume to keep track of the number of lights that are highlighted from 0 through 10. Now a mixer voice's .level property sets the volume, but it's not from 0 to 10, it's from 0 to 1.0, 1.0 being full volume. So what we'll just do is we'll take our volume and divide it by 10. This will give us a full level value of 1.0 when the volume is 10. Now let's open the terminal, save the code, and check things out. So it starts at volume 0, all lights off. Let's raise the volume to 2 and press a pad. Ooh, the pads are off by 1. I should add 1 to I before printing. So that was not full volume, that was at 2. Here's half volume.
A code monster you have become. Skilled you are.
Full volume.
A code monster you have become. Skilled you are.
1 volume.
A code monster you have become. Skilled you are.
No volume. And if I press a pad, I can't hear anything. Ah, and look at this. So I'm pressing A and I'm not seeing any lights change. Do you know why this might be happening? Okay, now they showed up. What's happening is it's actually playing this sound behind the scenes, but because our play function has a while playing pass loop, the code is frozen until playing ends, even if it's playing at 0 volume. Can you think of a way that we might change this so that we don't play an unheard sound when the volume is at 0? You might want to pause and figure it out as a mini challenge, but if you want to resume or just see right away, or if you know the answer right away, this is how I'd make the change. So first, let's print the proper pad number, and it's not really that important. I didn't ask you to do this, but remember, this for loop here is a range from 0 to 6 because the length of this touchpads array is 7. Now the touchpads on the board are actually named 1 through 6 plus TX. We can call that one 7 for purposes of printing. So I'll just add 1 to I inside of the curlies, and now this is going to be more accurate. But the real issue that we noticed was that we didn't want to play any sounds if the volume were 0, because otherwise it would just look like our board was non-responsive if we were trying to press button A and not getting any results because there was actually a sound playing with the voice level as 0. So what we can do is just before we call play underscore MP3 underscore voice, we can say if volume greater than 0, then indent the play MP3 line below this, and that's it. So let's run our code and see the fix. And I saved, and I don't see my code running on my board. Sometimes I just add a space and then resave above. Other times you can tap reset on your board. That might work. But there we go. We can see code.py, so the code's running. So sound play with volume 2 works. Now let's go down to 0, no lights, and press a pad. Then press A again, and we can see this lights and responds right away, so we're no longer playing a sound at 0 volume, so there's no longer a delay when we press A with volume off. Nice! So let's save this to our CircuitPy volume, and close the outermost tab, and feel good about your ability to combine prior projects to solve a new challenge. Rating code that works and combining pieces from one project into something new is a vital programming and maker skill. Continue to learn big, and as always, make awesome.